This lesson is about icosahedrons, spherical shapes made from mitered triangles. Now, I made my first icosahedron about 29 years ago. I happen to know that because my son, who's 31, was 2 years old at the time. I just happened to have that very toy. It's never been turned, but it was constructed as an interactive toy. It's got all these puzzle pieces that fit through. Anyway, years and years later, when I started playing with the lathe, it occurred to me that I could take shapes like this and put them on the lathe and turn them. And so that's what I want to show you next. What I have in mind is I'm going to make 3 small icosahedrons. Perhaps I'll convert them into candlestick holders. If I measure this triangle length and compare it to the icosahedron diameter, I can get a ratio. In this case, it'd be 5.5 inches divided into the 8.5 inch diameter. It gives me a ratio of 1.5. Using that ratio for my spheres that I want to start off at, say, 4.5 inches, by just doing the division, 4.5 divided by 1.5, I need triangles approximately 3 inches long, and for these other sides the same kind of calculation works. For these spheres, I'm going to use triangles that are constructed from 4 smaller triangles. A center triangle of ebony surrounded by 3 triangles of holly surrounded by 3 strips of ebony. Here's some ebony and holly that I've milled about 1 inch wide and about 1/2 inch thick. But before cutting any of that material, I want to make sure my saw is dialed in exactly at 30 degrees. This is all about fighting cumulative error. 29.95 degrees isn't close enough. If these are equal, then any side will perfectly match any other side. 6 of these, held with a rubber band, should form a perfect assembly. It looks like I'm set. I can start cutting my small holly triangles and my small ebony triangles. You may notice I've got a new saw, a Festool Capex saw. And you may notice that I'm not holding the material against the back fence like I have in my previous shots. The saw has such a nice slow start. There's no vibration, there's no shake. The material stays against the fence. For each of my spheres, I need 20 triangles made up of these 4 small triangles, but I'm making 24 of each size just to be on the safe side. I'm going to glue them together using rubber bands. This little triangle here with a piece of tape, they'll be used as a way to put pressure on the seam. With the use of those little triangle pieces, I'm able to put pressure in 6 different locations towards the center of this configuration. The 3 points of holly are being pushed towards the ebony triangle, and these 3 add-ons are keeping the seams nice and straight. It seems to work pretty well. It's a one-step glue job, which would be difficult to do in multiple steps. I'll leave the rubber bands on for at least 30 minutes. The little triangles snap right off. A little touch-up on the disc sander gives me a flat surface, so I can true up one edge and put the edges on the triangles one at a time. Here's my edge material. I'm cutting them 2 at a time. These will go on 1 at a time so I can sand in between glue steps. The reason they have to go on 1 at a time is I want to be able to sand them flush with those other surfaces. I've cut them just a smidgen long so that I've got a tiny bit of overhang that I can go to the disc sander and get nice flush clean edges for the next set. Getting ready for that next piece of border, I need a flat surface first so I can touch up this edge. This is a little tricky. The ebony sticks out a little bit. I want to sand the ebony off without taking any more holly than necessary off. Very, very light sanding. Now, to glue that second piece on is the same procedure as the first piece, although these borders are a little bit longer. And the third piece of borders put on the same way, a little sanding followed by this clamp job. Now, the other 2 spheres are slightly smaller, so the material gets ripped a little teeny bit narrower, And I'm even going to run these through a drum sander on edge just to create very precise dimensions. And then the same procedure of cutting and gluing to make those. So I've produced 3 different sets of triangles. They vary slightly in overall dimension. They've been dis-sanded smooth on one side, the other side's pretty rough, and I need nice parallel surfaces in order to go to the next step. So to create those nice parallel smooth surfaces, I mounted my pieces on trays of MDF with some strips of double-sided tape. After passing these trays through my drum sander, several passes, I'll have nice parallel surfaces, nice smooth surfaces, which I absolutely have to have in order to make nice accurate miter cuts. That's the next step. To produce those perfect cuts, my saw has to be dialed in dead on at 30 degrees of miter angle, 20.905 degrees of blade angle. This takes a little trial and error. I'm cutting miters on those original test pieces, the MDF triangles, one cut followed by a rotation, followed by another cut, and so forth. I'll take 5 of these pieces and tape them together into a ring or an assembly. It's that blade angle that's probably the most difficult to achieve. It has to be perfect. You've got to do a trial and error as many times as it takes to get perfect joints. I can now cut my good stuff. The sequence is to cut one edge on all the triangles before adjusting the stop block a tiny bit in order to cut the second miter, and then adjusting the stop block once more to cut the third and final miter. You have to hold really good down pressure, because once the cut is made, there's nothing touching the back fence that you've cut off that tip, so the only support is along the stop block, so good downward pressure is required. My saw has produced some really nice cuts. They're super smooth. There's no evidence of a saw blade. There's no need to sand these. Here I'm just going to rotate positions here. These should be perfect matches regardless of how they're positioned to one another, and they are. Here I'm going to do a test fit of 10 pieces. I've aligned them as perfectly as I can, putting a piece of Gorilla Tape on there. I'll cut the ends off and fold this into a ring. It should be perfect. There's no sense in gluing it together if this doesn't make a perfect circle. It's probably unrealistic to think I can perfectly align all the tips, and they'll get in each other's way, so I'm just knocking the tips off these. In preparation for the glue job, I'm now adding the last 10 pieces. I'm trying to line up the edges so everything stays in nice straight lines. They have to be straight lines no matter which direction that you examine them from. So I've laid it out here upside down and using this straight edge, just checking all these alignments. The alignments have to be perfect. I've got one here that's just a little bit off to the side, so I'm just shifting it a smidgen. You probably can't spend too much time checking the alignment of all these pieces. All these straight edges, they really do have to be straight or it won't go together. You'll have some thick, unacceptable glue lines. Now once I've got it as good as I can get it, some more Gorilla Tape secures everything together. The Gorilla Tape is a terrific material for this. It's really tough and it's really sticky. This is going to hold everything from slipping when I do the glue job. Before doing that glue job, I can roll this into a sphere and secure it with 6 rubber bands. You'll notice there are 6 equators where a rubber band or hose clamp will miss all the tips. During the actual glue job, I'll provide some additional pressure with hose clamps in these same positions. To give myself a little more working time, I've had my glue bottle sitting out here in the snow for about 20-30 minutes. It's probably down around 50 degrees. You have to be very precise and methodical in the way you get this glue spread. You gotta cover all surfaces. Normally I use Gorilla Glue on these kind of assemblies. But this one's fairly small. I think I can go fast enough. I'm going to take a risk and use Type Bond. The spreading of the glue, I'm using a little piece of wood that's shaped that fits that groove. It just helps me speed up the process of spreading the glue. Being very cautious not to miss anything. The use of this jar or a canister or a bucket, something the right shape and size, acts as a third hand for me. I can place it in there as I put rubber bands and then hose clamps. I'm going to speed this up and show you the whole glue job. That glue job took about 6 minutes to do. My glue has been cooled. My shop is probably around 60 degrees. This is all assisting me in giving me a little more working time. I need as much working time as I can possibly get out of this. You know, just like any clamping job, I want the glue to stay slippery until I've applied the full pressure. Now here's the glue job in a time lapse. I've compressed this down to about 1 minute out of the actual 6 minutes, but it'll give you the overall view of just how this is done. Fast work, but also being very careful, again, to not miss any surfaces. And then during the clamping, I'm paying particular attention to the open seams, the seams at the end of the tape perimeter. Those are the ones that could slip out of place. The seams in the middle of the tape job, with the strength of that Gorilla Tape, those pieces seem to, do a pretty good job of staying in place. I describe this type of project as risky, not because of any safety concern, because of all the time that's invested, the expense in the wood, and then the possibility at this stage of the game of just totally blowing it, making a mess of this clamping job, and then you've got a piece of junk that you've got to throw away. Well, it's the next morning, and it's time to see just how successful I've been. This is a bit like opening a gift on Christmas morning. So far, so good. I'm going to knock the tips off just so I can find the intersection points. And I'm going to mark those points with an awl. Then I'll go over to the drill press. I'm going to drill a pair of holes opposite one another. I'll be able to use those holes to properly line this up on the lathe for turning. For mounting it on the lathe, they've taken an old tailstock cup center, ground a few teeth on it, mounted it in my chuck. This gives me the ability to perfectly center this sphere on my lathe. That's important because I don't have a lot of wood that I can waste. My first turning goal is just to get down to the flat spots that are in the middle of each triangle. Once I've achieved that, I'm going to be very close to a round form. My next challenge is to get rid of those tips at either end. To mount these the other way, I'm going to use a cup center. I'm turning this out of some MDF. Nothing too fancy. I'm just checking the radiuses here. To hold my spheres into the cup drive, I'll use another cup pushing in from the tailstock end. This is very, very delicate turning. A lot of work's gone into this. I don't want to mess it up at this point. I've now got my spheres rough turned into a pretty round shape. I want to put these little teeny plugs in those intersections just to take care of the void that's there. A little glue, and these tiny plugs will improve the appearance of all these intersections. My next step is to prepare the tops and bottoms of the spheres, the bases and the candle holder. I've stacked 4 layers of MDF here, 3/4 inch MDF. I'm turning an opening that'll fit the smallest of the 3 spheres. I want to size this for my smallest one first so I can reuse the chuck over and over for the next 2 larger sizes. Now, in addition to having this jam that fits my sphere, I'm going to put a keeper ring on top. So I've got another layer of MDF here, drill 3 holes. Now I'll go over to my drill press and get those holes plenty deep and straight. I've got large, long screws that are going to go in there. I'm enlarging these just so the screws have room. Screw this on. This is one way. But if you've got magic screws, they just go in by themselves. To create the keeper ring, I'm just removing the bulk of the center there with a parting tool. and then undercutting with a scraper tool just to try to match up the diameters roughly. They don't have to be exact. This ring is going to be screwed in place, which will prevent the sphere from moving at all during the actual turning. To center the sphere perfectly, I've drilled a hole here, a small hole which will allow me to center this perfectly in my jam chuck. A little screwdriver work and I'm ready to turn this. This is going to be the base of the candle holder, and obviously it needs to be flat. What I'm going to do is install some concentric rings of holly and ebony. So next I need to go actually put some rings together that'll give me material to put into this opening. So I've produced 3 rings of ebony and 3 rings of holly, one of each for each of my 3 spheres. These are just standard, segmented ring constructions. Here's the holly ring that's been mounted on a waste block. I'm turning it roughly to the same diameter as my opening. The challenge in putting a plug inside an opening is you can't tell what's going on inside here. You can see what's going on the outside, but you can't see what's going on the inside. So the technique I like to do is I'll turn this opening to approximately the right diameter, but I'll leave a very radical taper, not a slight taper, but more like 5 to 10 degrees of taper. Then I'll take my plug, turn that to the right diameter, or approximately the right diameter, with a very slight taper, just a few degrees. Then, as I put this piece back on the lathe, I'll test this fit with a slight taper on the plug and a radical taper here. I should bottom out on the inside. The contact point, the first contact point, will be to the inside. And then by gradually removing wood on the inside of this opening, the plug will go in deeper and deeper. And as I sneak up on this perfect fit, the last wood removal on the inside will close up any gap here on the outside, and I'll have a good fit all the way through. Whereas if I have a tight fit on the outside and I ignore that inside, I have no way to know whether I've got a good fit going all the way through. Sneak up on it by making this inside taper less and less as you put the plug in. Here's an illustration to help you understand this more. The red outlines the opening, the blue is the plug. You can see how I've started off here, but as I remove more wood just on the inside of the opening, the plug will be able to go into the opening deeper and deeper, and I'll be able to sneak up on that fit. That's what I'm doing here. I'm just taking a little more of the ebony off towards the inside of the hole, and I'm checking my ring of holly, turning a little more ebony off. I'm trying to, slowly close up this gap. There's still a tiny gap right there. One more little, smidgen of removal, and I've got a good fit. I can glue this piece in. That pencil mark there, that just shows where my seam is, so I know how to place that. After it's set for 30 minutes or so, I can part off the waste block, prepare for the next ring, the same procedure, sneaking up on that fit. Here's the tapered ring that'll go in next, the ebony layer. The pencil marks again tell me where to position it, so I have a brick-laid set of seams. I can part that off now, prepare that for the final holly plug that's going in the middle. Sneak up on that fit, the same procedure, glue that one in place, part that off, finish turn this bottom. Doesn't take much turning to get this prepared. A little bit of sanding will follow this. I'll even put a couple of scored lines on here just to add a little decorative feature. Once I'm done with this bottom, it's a matter of taking it out, reversing it so I can prepare the top of this sphere. The top is going to have a little inset to hold the candle. After finishing the first one, it's a matter of enlarging the jam chuck for the next one. Also enlarging the keeper ring just slightly. Then I get to do it all over again. Once I finish this one, do the same thing for the third one. Now, using that opening at the top of the sphere, the one that was turned for the insert, I can fit those openings onto a jam chuck, a post that's been turned to fit that. It bottoms out very nicely on there. And this little padded piece of MDF, that'll secure it against my jam chuck post. Now, just a little bit more turning and these things will be ready for some sanding sealer. I'm not going to sand this on the lathe as it spins. I'll put sanding sealer on, and then I'll power sand using 320 and then 400 grit paper. I'm trying to sand away from the holly towards the ebony to keep that holly nice and clean. It is a challenge to keep that holly nice and white, but it can be done. It just takes a lot of care. After I signed these pieces, they were finished with Death spray, gloss followed by Saturn, and the very last step was to epoxy in place the metal insert for the candles. Here's a few examples of some of my older work that I did using the icosahedron. This is called Alice's Garden. The center components all connect to an icosahedron. The next one here is Cosmos, all the little boxes on the center sphere, icosahedrons. The Juggler, again, a large icosahedron in the center of this one. The next one, Platonic Molecule, a little tribute to Plato. Another tribute, this one to Buckminster Fuller. Bucky was right. And Pearls from the Forest, this is just the base of that piece. And I'll let you guess who this barbell for a princess was made for. Before I wrap up the lesson, let me give you a little more advice. I built my spheres from triangles like this, and after all the milling and gluing sanding, this thickness ended up being just under 1/2 inch. And for the smaller two spheres, that was okay. For the larger one, I came dangerously close to running out of adequate wall thickness. With hindsight, especially with the bigger one, I should have milled these at, say, 5/8 of an inch. And if you try to make bigger spheres, this one's 4.5 inches. If you go any bigger than that, then you probably should start off with 3/4 inch material. What I want to advise you on, though, is the cross grain elements. These are fairly small. The grain's going every which way. I don't anticipate having a problem with wood movement. But in larger sizes, the grain orientation becomes a bigger factor. And to be on the safe side, I would advise you to keep these kind of constructions at 6 inches and under. I've done bigger ones, and they've held together fine. A few of them, little teeny ridges have developed where the wood is moved, but they still look fine. But in general, I would advise you to keep this dimension, the overall diameter, at 6 inches or less. I hope you give this a try. They're not that difficult, and there's a high level of how'd you do that factor. Once you've got your saw set up, so you can cut those accurate angles, make more than one at one time, because inevitably, not every one of them is going to glue together perfectly. Good luck.